function to that? No. All right. So, if you have like this situation, sine some multiple of x is equal to some number, what are the typical sine values? Well, how about square root of 6 plus square root of 2 over 4? Is that a well-known value? Yeah, I kind of remember seeing that one somewhere. Which one was it? What is that? It's approximately, square root of 6 is, oh dear, 2.4 something? 2.45 maybe? So this is approximately 2.45 plus 1.44 over 4, which is 3.89 over 4, which is what, 0.9 7, approximately, I should say. Not exactly 0.97, but it's pretty close. And so, yeah, I would say that's probably the one that's up near the North Pole, right? Santa Claus. So if you say here's pi over 4, then these are pi over 3 and pi over 6, right? But that leaves a gap here and a gap here because this is 5 pi over 12, and this is pi over 12. And you count by pi over 12 6 times to get to pi over 2 at the North Pole, right? So I think that's probably this one, right? So this is the angle whose sine is square root of 6 plus square root of 2 over 4. That look right? So this is going to be like very close to 1, right? About 0.97. Less than 1, right? It's got to be less than 1. Or 1, I suppose, at pi over 2. Okay, so when we say it's equal to that, what else could it be? Well, it could be 7 pi over 12. That has the same, 7 pi over 12 has the same y coordinate, right? And what is that? That's the supplement, right? So these two angles are supplementary. This angle is the same as this angle, right? So together they add up to 12 pi over 12, which is pi, or 180 degrees if you think of it that way. So there are two solutions, right? So we'd say mx could be either 5 pi over 12 plus any coterminal angle. Right, so this is where k is any integer. Right. Z being the set of integers, Z being the first letter of the word integer in German. Zeigenganja or something. That's or, right? So is it clear what this 2 pi k is doing here? Because you could go here, or any coterminal angle, right? So if you add 2 pi to that position, you get back to where you started. 2 pi is once around the circle, right? Or any multiple, any integer multiple. In fact, k could be negative. You can go backwards, clockwise around the circle. What else could mx be? Well, it could be the supplement, right? So 7 pi over 12 plus 2 pi k. understand k is some integer, right? All right, and so have we solved for x? We solve for mx, and that's the first step. So when you have an equation like this, where you have trig function of some multiple of the angle x, you want to first solve for that multiple and find all solutions for that multiple, right? So say that this multiple of x could be any angle coterminal with either 5 pi over 12 or it supplements 7 pi over 12. Then solve for x, right? So let's say that is then x could be either, shall we put them together on one equation? So that'd be 5 pi over 12m plus 2 pi k over m, or 7 pi over 12m plus 2 pi k over m. This is a 2. My 2's get a little bit lazy. There, proper 2. So, how many solutions are those in one revolution, right? That's sort of a question. So we could say, well, let's say that n equals 4, right? Find all solutions to cosine. Uh-oh, what happened? Cosine? All right, sure. And let's make that minus. What happens if there's a minus there? Well, that's, if I were subtracting instead of adding, yeah, what would I get? 1.01 over 4, that's going to be pretty close to 0.25, huh? Yeah. A little bit more than 2.25? 0.26? No, maybe. So just 1.01, so you'd have 2 and then 80. I guess I should use a calculator, right? Because I'm just going by memory here. Not a good idea, huh? So I've got square root of 6. Did I remember that right? 2.449, that's pretty close to 2.45, right? Oh, yeah, this is the one that's wrong, isn't it? What am I doing with 1.44? That's closer to 1.41, isn't it? Okay, so then this is different. Should have called me on that. So that's going to be 3.04, is that right? Sorry, if I'm adding, I'm going to get 3.86. Yeah, something less than what I had before. So yeah, that makes this a little bit smaller, doesn't it? So that's going to be 26, so like 6. What I got, 0.97, so I wasn't too far off. But now when I subtract, that's going to be like 1.04 over 4, which I think that gives me 0.26. So where am I on the unit circle then? Here's pi over 4, there's pi over 6, and pi over 3. There's pi over 12 then. All right, so that's where I am, right? At where cosine. Oh, wait, it's the same place I was before. Right, I'm up here, not down here. But it's cosine. So this is what, 5 pi over 12 again? And cosine here is approximately 0.26. Huh? Does that look reasonable? Like, it didn't make perfectly evenly spaced hash marks, so this is a half, right? It's supposed to be a half. And this is about 0.707 for these familiar trig values. This is 0.866, and this is 0.96 apparently. As you approach, as the angle approaches 0, the cosine approaches 1, right? But up here, where it's okay, so this is the same angle as here, right? 5 pi over 12 again. But now we have a different kind of symmetry, right? So sine has y-axis symmetry, cosine has x-axis symmetry, and so what's the other angle? Well, it's down here, and how do we describe this angle down here? Where this is the same as this, right? Well, this is 3 pi over 2 here, right?